created by MindSticks Foundation Trust. Welcome, students. Today, we are going to master the art of translating confusing English word problems into simple, simultaneous equations. We'll be looking at translating words into math, upstream and downstream speeds, distributing money and wages, puzzles of numbers and ages, and finally, putting together your math toolkit. Section 1. Translating words into math, the art of translation. You know, a lot of students feel a sudden wave of math anxiety when they look at a dense paragraph of text. But here's a little secret. Word problems are not a test of your English comprehension, they are simply an exercise in translation. It's exactly like translating a sentence from Hindi to English. So let me ask you a question to get our minds working. How do we turn a flowing river's current into an algebra equation? Think about it. How do we take a physical, powerful force of nature and capture it perfectly on a piece of paper? Section 2. Upstream and downstream speeds. Navigating the river. Let's dive right into this by visualizing a classic scenario of boats navigating a flowing river. Imagine a boat that travels 16 kilometers upstream and 24 kilometers downstream, all in 6 hours. To solve a puzzle like this, we must patiently apply our translation rules. We start by letting the speed of the boat in still water be our variable x, kilometers per hour, and we let the speed of the water's current be y kilometers per hour. Now notice how these two physical states contrast brilliantly. When you travel upstream, against the flow, the water current is actively fighting your boat. It literally subtracts from your natural speed. So our translated expression becomes bracket x minus y bracket. But when you turn around and go downstream, the river pushes you along. It adds to your speed. Therefore, the downstream speed is translated as bracket x plus y bracket. By just remembering the simple formula that time equals distance divided by speed, this entire physical world of rivers and boats is neatly captured right inside our algebraic brackets. Section 3. Distributing money and wages. Everyday math. Moving from the river back to the classroom, here is a highly relatable everyday situation. Imagine a certain amount of money is being equally distributed among a certain number of students. The English sentence we are given has two distinct conditions. First, each student would get 2 rupees less if there were 10 more students. And second, each would get 6 rupees more if 15 students were less. Let's set up our foundation by letting the total number of students be x and the amount given to each student be y. Let's break this down step by step. Step 1, students are x, and the amount per student is y. Step 2, that means the total amount of money we are distributing is simply x multiplied by y, or xy. Now we translate line by line. For condition 1, the phrase 10 more students becomes bracket x plus 10. The phrase 2 rupees less becomes bracket y minus 2. When we multiply these two brackets together, it must equal our total amount, xy. Similarly, for condition 2, 15 students less is bracket x minus 15, and 6 rupees more is bracket y plus 6. And again, that equals xy. By expanding these brackets, the xy terms cancel out beautifully on both sides, leaving us with two very basic linear equations. Section 4. Puzzles of numbers and ages. Abstract logic. Now, let's challenge our minds with a slightly abstract logic puzzle. This is a tricky one that comes up in examinations quite often. A 2-digit number and the number with its digits interchanged add up to 143. To translate this, we have to break the number down into its core place values. Let's say the digit in the units place is x, and the digit in the tens place is y. Because y is in the tens place, its actual mathematical value is 10 multiplied by y. So our original mystery number is represented as 10y plus x. Think about how the logic flows here. If our original number is 10y plus x, what exactly happens when we interchange the digits? Well, the x moves over to the tens place, and the y moves to the units place. So our new interchange number is 10x plus y. The problem says adding them together gives us 143. That gives us 11x plus 11y equals 143. We can simplify that by dividing by 11, giving us x plus y equals 13. That's our first equation. A second condition in the problem tells us the units digit is 3 more than the tens digit. Translating that, we get x equals y plus 3. Look at that, we now have two simple, manageable, simultaneous equations. And what happens when we solve them? We get the number 58. Let me tell you how. By substituting x equals y plus 3 into our first simplified equation of x plus y equals 13, we find that x equals 8 and y equals 5. Now place those values back into our original format of 10y plus x. We get 50 plus 8, which is 58. Absolutely brilliant, right? It's a beautifully precise answer, derived entirely from translating confusing words into structured mathematical logic. Section 5, your math toolkit. Practice makes perfect. Now that you understand the art of translation, take a look at the incredible variety of problems you can solve with this new toolkit. In our source materials practice set, we see a whole world of scenarios. Whether you're finding two numbers that differ by 3, calculating the perimeter and area of a rectangle, determining the ages of fathers and sons, finding the numerators of complex fractions, weighing heavy boxes in a 10-ton truck, or even calculating the speeds of aeroplanes, the underlying mathematical translation rules remain exactly the same. You just assign variables, x and y, carefully build your conditions, and solve. I want to conclude this explainer by leaving you with one final puzzle to test your new skills. Places A and B are 30 kilometers apart on a straight road. Hamid travels from A to B on a bike. At the exact same time, Joseph starts from B, traveling towards A. They meet after 20 minutes. But if Joseph had started from B in the opposite direction, Hamid would have caught him after 3 hours. So, my dear students, here is your challenge. Can you translate these conditions into equations for x and y? Can you find the exact speeds of Hamid and Joseph? Pick up a pencil, apply your math toolkit, and see if you can decode the mathematics hidden in these words. Thank you for joining me, and happy translating.